Hello students, welcome back. We went through one example on related rates. Wasn't too bad. Now let's go to the second example, and this one is going to be a bit harder. A water tank has the shape of an inverted circular cone with a base radius of 2 meters and height of 4 meters. If water is being pumped into a tank at the rate of 2 cubic meters per minute, find the rate at which the water level is rising when the water is 3 meters deep. From this, can you get an equation? Well, we're talking about circular cone. And then we are talking about amount of water with unit of volume. So yeah, it's got to be the volume formula for a cone. So volume is 1/3 base area times height. Remember this? What's the base area? It's circular cone, so it's pi r squared. What's the height or depth? Because this is inverted. There goes your first equation, but your trouble is just beginning. Unlike the previous problem where you have 2 characters, you have 3 this time. So you have this one equation with a relation between 3 variables, and you're going to get the second equation by taking the implicit differentiation. So the relationship between the rates. Consequently, you get 6 unknown variables with only 2 equations. Somehow you'll have to reduce to 2 unknown variables and 2 equations. That's the challenge you have. Any idea? Stop the playback if necessary and think about that. Well, I'll give you a bit more hint here. So we have inverted circular cone, and water is being pumped in, so water level is rising. So H is getting bigger and bigger and bigger, and consequently this radius is also getting bigger and bigger and bigger. And then total is 4 meters, and the radius is 2 meters. Okay, those are labeled accordingly. Is that sufficient? Water is being pumped into the tank at the rate of this, so something is equal to 2. What is it? But it says at the rate of, so the rate is 2 cubic meters per minute. So what is equal to 2? Can you figure it out? And then find the rate at which the water level is rising when water is 3 meters deep. Okay, so what is equal to 3? That one is a bit easier. And final question, what do you want? Rate at which water level is rising. What's the quantity I want? Let's answer those 3 questions before conducting the implicit differentiation. There's a reason I'm doing it in that order. Okay, what is equal to 2 cubic meters per minute? At the rate of, so it's not just volume. You see, cubic meters, that's unit of a volume, but at the rate of. So it's not V, but V prime is equal to 2. That's what this condition, this number is giving me. Okay, all right, we have 1. Now, what is equal to 3? when the water is 3 meters deep. Oh, depth is 3 meters. So this is inverted cone, so height of this inverted cone is the depth, so h is 3. Does it make sense? Let's put some space in between. So v prime is 2, h is 3, okay. And what do you want to find out? Find the rate at which water level is rising. So is it, well, it's a rate, so it's a derivative. So some kind of prime. What is it? Is it v prime, r prime, or h prime? Rate at which water level is rising. It's water level again, so it's a prime. That's the quantity you want to find out. So v prime is equal to 2. Let me emphasize in color blue. And h is 3. Let me emphasize it in color green. And h prime, red. So that's the quantity I want. Okay, why did I get these before taking the implicit differentiation? There's a reason, because we want v prime, and h prime, those four. R somehow must go out. So somehow reduce this into an equation of 2 variables only. How do you do that? That's your second challenge. The first challenge was, well, volume formula, of course, you should know, so I do not count if it's really challenging. The first challenge was getting these three. V prime is 2, h is 3, and h prime unknown, all from the second sentence here. What is equal to 2? What is equal to 3? And what do you want? Now, second challenge. How do I remove r? Stop the playback if necessary and think about it. Well, have an idea? It must have something to do with this 2 meter, 4 meter something, because these numbers, I didn't use those yet. Okay, all right. Here's the answer key. We start from there. Okay, 1/3 pi r squared times h, no question about that. Now, let's find out the relationship between r and h so that let's remove r. How can you do that? Well, this picture looks nice, but it gives you too much information. 3D pictures frequently gives you too much information. 2D picture in a cleverly selected viewpoint sometimes reveal more. Reveal less as a matter of fact so that it's easier for you to see. So this picture, this 2D picture is easier. You see, this gives you too much information. So look at it at this level, horizontal level, then you're gonna see a right triangle instead of this circular cone, like this. So 4 meter high, 2 meter, and from here we can find out the relationship between r and h. You see, 4 meter is twice as 2 meters, and we have similar triangles, so height must be twice of r. Or, equivalently speaking, the radius is half of height. Make sense? Full radius is half of the full height. So current radius is going to be half of current height or current depth. If you want to use geometry, you can use this proportional equation to solve it. But it's going to be easier to get directly from the picture. 2 meters is obtained by half of 4 meters. So r must be half of h. So plug that into the original equation. R is half of h. Let's see. This one. Let me use different color. Let's see, magenta. And consequently, this goes here. So here, plug in there, and half of h squared times h. So if you simplify, let's see, h squared times h, so we have h cubed. And then 2 squared is 4, so you get 3 times 4, 12 in the denominator. Make sense? Once you have this, you're now ready. You can take the derivative implicitly to get the second relation. Here we get the relationship between v and h and nothing else. No r anymore, just v and h. Take the derivative implicitly, you get, take the derivative implicitly, you get the relation between v prime and h prime. Or, as I wrote here, dv dt and dh dt. Just implicit differentiation. So take the derivative by h, so dh dt popped out. Okay, all right. Equation number 1, which I'm highlighting in bold. Equation number 2, I just highlighted it in bold. 2 equations, and we need 2 unknown variables. Yeah, v prime is 2, okay, that's 2. And then h is 3, so that's 3. So plugging in, v is 9/4 pi, and of course the problem did not ask you that, but you could have answered it. And then from the second equation, you get relationship between dh dt and dv dt, h prime and v prime. With all those numbers plugged in, you can solve for dh dt. So what do you get? Divide all these. 9 pi over 4, so divide, so we get 8 or 9 pi. Do your computation, and you're going to get about 0.283 meter per minute. Okay, there you go. That's a full solution. Let's see, we have a little bit of time, so let's review. We begin with the volume formula of a cone, no question about that. And then let's analyze the second sentence. What is equal to 2? What is equal to 3? And what do you want to find out? V prime is t, or dv dt, and height is 3. I used red there, so let's go back. And h prime, rate of change of height. That's the quantity I want. But there's a problem. We have r, so we need to remove it. We have to get a relationship between v and h alone, no r. So how do I do that? It comes from the picture, but this picture has too much information. Let's get down to a 2D version by looking at sideways. So the radius of this big cone, the original cone, is half of the height. So current radius must be half of the current height, current depth I mean. So instead of r, plug in 1/2 of h in there, and you get this equation here, which can be simplified into this one highlighted in bold. There goes our equation number 1, the relation between v and h. Taking the derivative implicitly, we get the relation between the rates, v prime and h prime. Plugging the numbers, v prime is 2, h is 3, so we get v computation like this, and an h prime computation like that. Solving for h prime, we have the answer, 0.283 meters per minute, approximately speaking.